Okay, let's unpack this. You're listening to this deep dive right now, probably on a device, right? Powered by tiny, invisible miracles microchips. And at the heart of nearly all of them, there's one company, maybe you've never heard of it, but its influence, absolutely monumental, TSMC, Taiwan Semiconductor Manufacturing Company. And this isn't just about, some company. It's really about Taiwan's central, almost sacred role in this global industry that touches, well, everything in our modern lives. Just to be clear, when we say at the heart, we mean they are the silent engines. They're a foundry, basically, a company that specializes just in manufacturing chips that other companies design.
Exactly. And what's truly remarkable here is that TSMC isn't just any foundry, not even close. It produces, get this, 2/3 of all chips globally. But then if you narrow that down to the most cutting edge, the really advanced chips, their share jumps to, well, a staggering 90%.
90%,
Yeah.
wow.
Yeah. So our mission today really is to understand why this behemoth is being pushed, nudged, maybe even pressured to expand beyond the sacred mountain of Taiwan. And, what's surprising, often challenging truths kind of pop up when it tries to replicate its success somewhere else.
And this is where it gets really interesting.
Yeah.
Because the global desire, this push for TSMC to set up shop in other nations, it's intense. It's driven by this powerful mix of geopolitics, national security concerns, economic hopes. But as we're going to find out, trying to replicate their unique success, it turns out to be incredibly complex. And it reveals some surprising, maybe even humbling truths about what actually underpins manufacturing excellence today. That's our central insight we're exploring. So let's dive right into the sheer scale of TSMC's impact. First, Taiwan, right? An island state, just over 23 million people. But it's responsible for this absolutely astonishing percentage of the world's semiconductor manufacturing. Think about that for a second. This relatively small island is the critical nerve center for, well, the vast majority of the world's most advanced tech. Your smartphone, the supercomputers running AI models, so much of it is powered by chips that start right there.
And if we connect this to the bigger picture, this huge concentration creates what people often call the silicon shield.
Right, the silicon shield.
Yeah. The basic idea is that TSMC's indispensability, the fact that the world needs it so badly, actually helps deter potential military action against Taiwan. Because its collapse or even just a long disruption would trigger, an economic catastrophe for the entire world. So it becomes this strategic asset, and protecting it is a national security interest for lots of powerful nations, far beyond just, simple economics.
That silicon shield concept is fascinating. And, okay, clearly it offers a powerful layer of protection. But it also sounds like, well, a really high-stakes gamble, doesn't it? Does relying so heavily on the world needing you actually make Taiwan safer? Or does it also make it an even more tempting, maybe even fragile strategic target for anyone looking to, disrupt global power? What's the counter-argument there?
That's a really crucial point, a very good question. While the silicon shield definitely provides significant leverage, right? It raises the global cost of any attack exponentially, which is a deterrent, but it also places Taiwan in an incredibly precarious position. The counter-argument basically says that this concentration of power, while it has benefits, also makes Taiwan a massive single point of failure. Any big natural disaster, an earthquake, a typhoon, and Taiwan gets those, or, escalating geopolitical tensions, could, just like that, cripple global technology. So while it offers a certain kind of protection, it simultaneously highlights Taiwan's vulnerability and the fragility of the global supply chain, which actually is exactly what drives this desire we're talking about for TSMC to diversify, to build elsewhere. It's really a double-edged sword.
A double-edged sword, yeah, that makes sense. And their leadership isn't just strategic. It's financially and technologically dominant, too. We're talking explosive growth. In 2019, TSMC's revenue was, what, $32 billion?
Around there, yeah.
By 2024, it's projected to hit an incredible $80 billion.
Yep.
That kind of growth doesn't just happen by accident.
Yeah.
And who relies on them? Pretty much everyone at the top of the tech world. Apple, Amazon, NVIDIA, Qualcomm, all these giants and loads more absolutely depend on TSMC for their best chips.
And what's truly remarkable is how they pull this off. It's not just about throwing money at it, though they do invest heavily. It's about this unparalleled manufacturing discipline, people describe as unbelievable yields.
Yields meaning?
Right. So think of it like, imagine you're mass producing incredibly intricate designer cakes. Okay? Every single one has to be perfect, identical, down to the tiniest detail or it gets tossed. Now imagine making millions of those cakes with almost zero mistakes. That's kind of the challenge in chip making. A tiny speck of dust, one tiny misstep can ruin a whole batch, a whole wafer of chips worth a fortune. And TSMC consistently gets near perfect results. Way better than the industry average.
Wow.
They have this extraordinary ability to quickly spot patterns, connect the dots, solve problems right there on the factory floor, often before anyone else even knows there is a problem. And think about the tech leap itself. Back in, say, 1977, a tiny chip might have held 25,000 transistors per square millimeter. Today, 2024, that number is over 200 million.
200 million.
Yes. And TSMC is right at the absolute cutting edge of that relentless innovation, pushing the boundaries of physics, really. And this incredible efficiency lets them produce 2/3 of the world's chips from just 1.5 square kilometers, tiny area, in the Hsinchu Science Park.
That level of efficiency, that density, it's genuinely astounding. But like you said, it's not just the physical space. It's about what drives that incredible output. And to give you a glimpse into their unique culture, the thing that makes this possible, there's this powerful story. A 7.7 magnitude earthquake hit Taiwan, a big one. Within hours, literally hours of this major disaster, they held a 2 p.m. meeting with the entire supply chain.
Wow.
To assess damage, figure out how to restart operations. That kind of dedication, that resilience, that immediate problem solving, even when the ground itself is shaking. It's just part of their DNA, apparently. It's this deep commitment that goes way beyond what you'd expect from a typical corporation.
Which really makes you think, right? It suggests that TSMC's lead isn't just about the tech or the money. It's deeply embedded in its organizational culture, its meticulously refined processes, and this continuous, almost obsessive adaptation that lets them hit that level of precision and speed.
Yeah.
It's like an alchemy of factors, really hard to pull apart, let alone copy somewhere else.
So, okay, this brings us to the next big question. For you, the listener, and for the global economy, why? Why are so many nations really pushing for TSMC to build these fabs, these fabrication plants on their soil? It's clearly not just about money. It feels like it's about this new, I don't know, more volatile global reality we're in.
Indeed. Yeah, the geopolitical motivations here are huge, immense. Nations, especially the U.S., are frankly desperate to reduce their reliance on Taiwan. Given its vulnerable position geographically, it's in an active earthquake zone. And geopolitically, well, the cross-strait tensions are always there. The potential for supply chain disruptions, whether from nature or conflict, is this constant, terrifying threat.
Right.
So diversifying chip production is now seen as a critical national security imperative. No major power wants to be caught without access to these essential components. They underpin everything. Advanced weapons, critical infrastructure, you name it. And it's not just the U.S. You see Germany, Japan, other European nations actively courting TSMC too. It underlines this universal geopolitical anxiety.
And this anxiety has led to direct, very public action, like the Made in America initiative, the U.S. CHIPS Act, for example. It allocates this massive sum, $52 billion, with $39 billion specifically for manufacturing incentives.
Huge amount of money.
Yeah, it's a direct effort to reshore chip production, secure those vital supply chains. The desire to bring chip making home is intense. But, some critics argue that forcing companies like TSMC to build these expensive, maybe less efficient fabs outside their perfectly tuned ecosystem, could that ultimately harm their innovation? Could it actually make the global supply chain less resilient in the long run? Is there a valid concern that too much political pressure might, unintentionally compromise the very efficiency that makes TSMC so vital in the first place?
That's a legitimate concern, absolutely. And it's a tension TSMC itself is wrestling with, no doubt. Look, from TSMC's perspective, this is an incredibly complex calculation. On one hand, foreign expansion offers political goodwill, right? It might unlock new markets, it diversifies their own supply chain risks to some degree. But on the other hand, it comes with significant cost increases, major operational challenges, and those can indeed impact efficiency. The company is trying to balance these national security interests of, the host countries with its own economic realities and the absolute imperative to maintain its technological edge. As the sources we looked at point out, money is not simply about money in this whole situation.
Right.
There are deeper strategic things, operational things, even cultural factors at play that really influence whether a new fab built somewhere else will actually succeed. It's a really delicate dance between national policy and, commercial viability.
Okay, so let's look at some real-world examples of TSMC's foreign adventure, as you called it, and see how this is playing out. First, the one that gets a lot of headlines. the Arizona project in the United States,
Yeah.
hailed as this major win for American manufacturing.
Yeah, the Arizona project, it has definitely run into significant hurdles, and it really reveals the complexities we're talking about. First off, the cost. For two fabs, it's a staggering $40 billion,
$40 billion.
which is roughly double the estimated $20 billion for similar facilities back in Taiwan. Double. And this huge cost increase comes from lots of things. Higher labor costs, more expensive materials, building all the infrastructure needed in a new spot. And crucially, it's not even for their absolute most advanced chips. These are, you might call them, traditional edge factories making 3-nanometer chips. Still incredibly powerful, don't get me wrong, but it's a step behind the truly bleeding edge stuff, like 2 millimeters or even 1 nanometer tech that TSMC keeps perfecting back home. So the U.S. isn't getting the absolute peak of TSMC's innovation, at least not right away. Then there's the labor front. There's been a significant shortage of the highly specialized skilled workers you need for this, especially in a region that isn't, traditionally a hub for advanced chip making. Beyond just numbers, the cultural differences have apparently been a substantial hurdle.
How so?
Well, the typical Taiwanese work culture, from what we understand, emphasizes very long hours, rapid, often on-the-spot problem solving, maybe a more hierarchical, direct communication style. And that sometimes clashes with different labor expectations in the U.S., union dynamics, different ways of communicating. This has directly impacted the work pace. It's led to delays in construction, delays in installing equipment. Plus, getting all the necessary permits environmental, construction has faced unexpected holdups, slowing things down even more. And, we shouldn't forget the long-term questions about critical resources, water and power in a desert location.
Right. Vital for chip making.
Absolutely essential. These fabs consume enormous amounts, so there are questions about long-term availability. All told, construction is projected to take maybe 5-7 years, which is much longer than Taiwan's usual 3-4 years for a similar fab.
Okay, 5-7 years versus 3-4. That's a big difference. Now, for a really compelling comparison, let's look at Japan. Their experience seems to have been notably, maybe even remarkably, different, smoother.
Yeah, the Kumamoto fabs in Japan. They tell a much more successful story, at least so far. The initial investment was more manageable, about $7 to $8 billion for the first fab, significantly less than Arizona.
Much less.
They've also achieved a significantly faster build-out. The first fab is already up and running, and they've already announced the second one in pretty quick succession. That suggests a much smoother, more efficient process overall. And crucially, there's been successful collaboration. It's a joint venture with local partners like Sony and Denso.
Ah, okay. So not just TSMC alone.
Exactly. That means they share the risk, they get access to an established local supply chain, and they can tap into Japan's existing pool of skilled workers. The cultural fit also seems to have been much better. Japan's emphasis on precision, long-term planning, a strong work ethic, that seems to align pretty well with TSMC's own operational philosophy, leading to, more harmonious and efficient operations. And the government support has been described as incredibly strong and effective, not just handing over cash.
Right. What else?
It's been tailored specifically to TSMC's unique needs. Things like fast-tracking permits, investing in local infrastructure around the plant, even providing subsidies for specific training programs for the workforce.
The differences are really stark, aren't they?
Yeah.
When you hear about these two approaches, the struggles in Arizona versus the relative successes in Japan, what factors, beyond just the financial incentives, do you think could explain why Japan seems to be working out better? It feels like it's clearly more than just the dollars and cents involved.
Precisely. Yeah, I think the Japanese model reflects a deeper understanding, maybe a greater appreciation, of TSMC's very unique operational needs. It seems like it's about fostering a truly effective partnership, one that goes beyond just financial incentives and really gets into the operational and cultural synergy that's so vital for this incredibly demanding industry. Japan offered, a pre-existing ecosystem, didn't it? A highly skilled, disciplined workforce was already there. A robust local supply chain existed, and a government that seemed very proactive in removing bureaucratic hurdles rather than maybe inadvertently creating new ones. That level of support, combined with perhaps a cultural affinity for manufacturing excellence, it meant Japan wasn't just offering money, they were offering a compatible environment. And that's arguably far more valuable to a company like TSMC than just a bigger check.
Okay, so let's shift our focus a bit then to what makes TSMC truly unique, beyond the amazing technology, beyond the geopolitics surrounding it. What aspects of this heartbeat, as one source called it, are so incredibly hard to replicate somewhere else? What is the real secret sauce, the sort of intangible essence that even billions of dollars can't just buy or build overnight?
I think the crucial point here really is the human element, and it's something that's been meticulously cultivated over decades. It's the almost unparalleled dedication of the workforce, from the top engineers down to the operators on the factory floor. Their willingness to work incredibly long hours when needed, to solve problems rapidly, relentlessly. There's this collective will to succeed that seems to define the company. And this wasn't just luck, it was, by all accounts, meticulously cultivated by its visionary founder, Morris Chang.
Right, the founder.
His whole philosophy centered on this pure play foundry model, meaning TSMC only manufactures chips for others. It never designs its own, which means it never competes with its clients. A brilliant move, really.
Builds trust.
Exactly. And it allowed them to pour all their energy into manufacturing excellence, nothing else. He instilled this culture of continuous learning, rigorous engineering, and an almost, well, familial dedication to the craft, where solving a problem isn't just a job, it's a collective mission, often requiring round-the-clock efforts to keep those incredibly complex machines running at peak efficiency. It's an ethos where perfection isn't just the goal, it's kind of the expected baseline.
So that's why, at the end of the day, TSMC's unparalleled success isn't solely because of its advanced machines or its huge capital. It's this deeply ingrained organizational culture, this commitment to manufacturing excellence that borders on, well, obsession, a relentless drive for continuous learning, and this almost familial dedication to the craft you mentioned. It's the human factor, the problem-solving mindset, the relentless pursuit of perfection, the ability to adapt and innovate so quickly that makes it truly exceptional, and therefore exceptionally difficult to just pick up and move somewhere else. That's the magic that seems so hard to replicate. So we've done a deep dive into the incredible world of TSMC, from its silicon shield protecting Taiwan to its, frankly, unrivaled dominance in chip manufacturing, the core insight we've landed on. While the global demand for its chips is immense, driving this intense push for expansion, our journey today has really uncovered that replicating TSMC's unique blend of technology, efficiency, and maybe most critically, its deep-seated organizational culture is proving to be an immensely complex and costly challenge.
And the contrasting experiences in the U.S. and Japan really illustrate that starkly, don't they?
Absolutely. And this raises, I think, an important question for you, the listener, to chew on. As nations quite rightly prioritize supply chain resilience, trying to bring critical manufacturing home, how do we balance that security imperative? How do we balance it with the complex, often unseen factors, things like culture, deep expertise, historical context, the sheer human will to innovate that make a company like TSMC truly exceptional? Is it actually possible to transfer the magic of such a unique entity? Or will its core advantages always remain deeply rooted in its original home, simply too intricate, too interwoven to successfully transplant?
Maybe the real deep dive here isn't just into microchips themselves, but into that intricate dance, the dance between global politics, huge economic forces, and that irreplaceable human element that shapes our technological world. And perhaps how much we truly understand what makes innovation really thrive in the first place. Something to think about.